Hello friends and welcome to Average Classes. Okay, so last class we have discussed about metacenter, that is stability of submerged body and floating bodies. In floating bodies we came to know about the rotational stability. In the rotational stability we came to know about the metacenter. It's the point about which your floating body oscillates. Okay, and we knew that when the m is above G it is positive, when m is below G it is unstable equilibrium. Okay, stable when the m is above G. Okay, so now I have to again three cases. In one case the G and P are lying on the same plane. So this is my which equilibrium? Sir, this is your neutral equilibrium. What equilibrium is this? Sir, this is the neutral equilibrium. Now in this case, because now it has tilted, the ship has tilted, so the B, what is your center of buoyancy? Your center of buoyancy has now shifted to a new place, that is B dash. So the force of buoyancy is now acting through B dash. So if I am gonna join this, this center of action or line of action of the buoyancy force will meet with the axis of this plane or the centroidal axis, and that point only we call it as what? Metacenter. That point only we call it as metacenter. In this case, the metacenter is above G, so there will be a restoring couple. Hence, which equilibrium this is? Sir, you already told this is stable equilibrium. Now, in this case, this is the line of action of the buoyancy force. This line of the action of buoyancy force meets somewhere here. This is my metacenter. In such case, metacenter is below centroid. So there will be a overturning couple or righting couple, and we call it as what? Unstable equilibrium. Unstable equilibrium. Okay, this is what we have studied. Now we'll study about the metacentric height. Metacentric height is the height between your center of gravity and your metacenter. It is the distance between the centroid and the metacenter. That only we call it as what? Metacentric height. GM. Metacentric height. GM is nothing but your metacentric height. That is the distance between the centroid and the metacenter. Very good. Now, how to write G? This GM. Sir, this GM is nothing but we have B into M minus BG. Sorry, B, not B into M, BM, the distance BM minus the BG. What is BM? Your BM is the metacenter radius or radius of metacenter. BM is what your? BM is nothing but your radius of, yes. Come on, radius of metacenter. Okay, very good. Okay, so this implies your metacentric radius GM equal to BM. BM value is I upon B minus BG. This is the formula. I naught you write, or I naught by B minus BG. What is I naught? I naught is the moment of inertia. Sir, moment of inertia of what? Moment of inertia of the plane. What? Moment of inertia of the plane which is in contact with the free surface of the liquid. See, this is your ship, let us say. So this shape, this much it is floating. This much depth it is floating. Okay. So on the free surface, this is the free surface of the liquid. On the free surface, whatever your on the free surface, the area which is coming, this is the area which is coming in contact with the free surface of the liquid. You can imagine, yes or no? This plane. So the moment of inertia about this plane is your I naught. Okay. What is B? So B is the volume displaced. B is the volume displaced by the body or ship minus BG. BG is the distance between center of buoyancy and centroid. BG is the distance between center of buoyancy and centroid. Sir, how did this formula came? This is a 3-dimension. You have to imagine little 3-dimension, and it has a separate expression. So this expression I will put in a very separate video. You can find that link in the description itself. I'm not going to discuss this now, otherwise your mind will blow off and you'll leave it in between only. Anyone who wants this derivation, okay, Already I have put it in the video, and the description you will find. The link you will find in the description. Okay, you understood? What is I naught? I naught is the moment of inertia about the plane which is in contact or which is in parallel with the free surface of the liquid. Okay, V is the volume of the liquid displaced here. V is the volume. V is the volume of liquid displaced. I naught is the moment of inertia. Bg is the distance between centroid and the center of gravity. So this is what sir, this is your metacentric height. Gm is the metacentric height. Very good. Very good. So why you are teaching now metacentric height? Because from metacentric height also we can define whether it is in stable equilibrium, unstable equilibrium, or in neutral equilibrium. Very good. So if your metacentric height, that is your Gm, if your Gm is positive, means what? M is above G. M is above G. So if your metacentric height is positive, M is above G, which equilibrium? Sir, stable equilibrium. If your metacentric height is negative, that means what? Sir, M is below G, means unstable equilibrium. And if your metacentric height is 0, that means M coincides with G. Very rare opportunity this is. Okay, M coincides with G. What equilibrium we call? Sir, we call it neutral equilibrium. We call it neutral equilibrium. Okay, got it? I hope you have noted down that before thing. Okay, pause the video, note it down fast. So you can note it down. Gm is the metacentric height, that is the distance between centroid G and the metacenter M. Gm equal to I by B minus Bg, where I is the moment of inertia about the plane or area which is in contact with the free surface of the liquid. Okay, this I is also your minimum moment of inertia, or moment of inertia about centroidal axis, about longitudinal axis, about, will just, you note it down, I'll explain why. Moment of inertia about the longitudinal axis. B is the volume of the fluid displaced, and Bg is the distance between the centroid of the fluid, that is centroid of the fluid displaced is what? B, and the center of the body, that is your G. Okay, note it down. I'll explain why I is the minimum moment of inertia or moment of inertia about the longitudinal axis. Now I'll explain why I is the minimum moment of inertia. See, this is the longitudinal axis. You will agree with me? Yes, this is the longitudinal axis. This is your transverse axis. Okay, so if I'll draw this is your longitudinal axis, this is your transverse axis. Okay, longitudinal axis. Okay, or let us say I am giving it as x-axis. This is your transverse axis, which is your y-axis. Sir, you can write this x or this y. Correct, yeah. You write whatever you like. Okay. Only remember, this is your longitudinal axis, this is the transverse axis. Okay, and this is the axis which is perpendicular to both, that is your z-axis. Okay, remember, in case of a this is your ship, this is the longitudinal axis. Okay, this is your transverse axis, and this is your z-axis. Okay, now about the longitudinal axis, if it is moving like this, okay, you call it as what? We call it as rolling. We call it as rolling. About the transverse axis, if it is moving, means like this, we call it as what? Pitch or pitching. We call it pitch or pitching. And about this z-axis, if it is moving, about the z-axis it is moving, we call it as yaw. We call it as what? Yaw. So this is your rolling. This is the rolling. This is your pitching. This is your yaw. Okay. So x and y and z axis you understood. So longitudinal axis what we call? Sir, you call it rolling. Okay. Transverse axis, sir, you said you call it pitching, and z axis it is yaw. Okay, understood? Very, very good. Now this particular area only I am drawing here. Okay, this only I am drawing here. Okay, this is your longitudinal axis xx, this is your transverse axis y. ठीक है ना? It was like this, tilt करके. Okay, longitudinal axis. What is this length? This length is L. What is this length? Let us say this length is your B. ठीक है? What will be your moment I axis? What will be the moment about x axis, sir? The moment about x axis, I axis will be my L into B cube by 12. L B cube by 12. That is your what? Rolling. Okay. What is your IYY? Sir, IYY about this axis is nothing but your B multiply L cube by 12. That is your pitching. That is your pitching. Now, in which case moment of inertia is less? Which case moment of inertia is less? Sir, in IXX, that is in the case of rolling, the moment of inertia is less. That means if you will design your ship for the minimum moment of inertia, of course it can take care of the larger one. Of course it can take care of the larger one. So that's why we design for minimum moment of inertia. And rolling causes seasickness. Okay, more rolling, it causes seasickness, and also the stress and strain are higher when this is a rolling case. Okay, rolling causes seasickness, and rolling also causes more stress and strain. So that's why if you are designing in such a way that it can take care of the rolling effect, that is your minimum moment of inertia, by default it can take care of this pitching wala thing. Okay, hence we always design for the minimum moment of inertia. Now you understood why I wrote I is the moment of inertia about the longitudinal axis. What is I axis? I axis is the longitudinal axis. Along the longitudinal axis we call it rolling or minimum moment of inertia. Very good. Note it down. Superb. So now let us take to one more interesting topic. Normally what I want more metacentric height. I need the GM should be more. If I need more metacentric height, that means the distance between B and B dash should be more. Okay. If the distance between B and B dash is more, what will happen? So sir, the couple or the moment which is because of the shifting of buoyancy will be more, because my moment is nothing but what is that, sir? FB into BB dash. This is your moment. So if BB dash is more, so this implies your couple or moment will be more. If that is more, your metacentric height is more. But if you do that, what will happen is your passengers who are inside the ship, they will have a high magnitude of moment. They will experience a high jolt, high magnitude of moment. So that's why if you are going for a passenger vehicle, we won't recommend metacentric height to be more. We want it less. Sir, how can you mathematically prove this? This can be mathematically proved if a floating body oscillates, then its time period of oscillation is given by t is equal to time period 1 by 2 pi root over of k square by small g into gm. What is k? Sir, k is your radius of gyration. K is the radius of gyration. What is g? Sir, g is the metacentric height. So what happens when your metacentric height is more? If metacentric height is more, then the time period of roll is less. That means quickly it is coming to original position. If quickly it is coming to original position, what we call, sir, stability increases. That means that kind of ship is more stable. So if stability increases, because the time period of oscillation is low, what it will have a discomfort to passengers. It will possess a discomfort to passengers. That's what I told you. They will have a higher magnitude of this moment they will experience, okay, at the less time. So that's why it will be very discomfort. Hence, if it is a cruise ship, or then your metacentric height is normally less. Less is the metacentric height, more is the time period of oscillation, little less stable, but it is comfortable to the passengers. If it is a cargo ship, normally the metacentric height is 0.8 to 0.9 meter, and if it is sailboat or warships, this metacentric height is more. More the metacentric height, more stable is the ship, and what do you call? But less comfort. Okay, note it down. Sometimes in exam they ask a question, that is, you have a cone whose apex is downward. So this is a cone whose apex is downward and it is floating in the fluid. So floating in the fluid. This is the question they ask. Okay, what they ask normally is what should be the what should be the depth of submergence, that is x. What is your depth of submergence x, they ask. So in order to calculate the depth of submergence x, we need how much? We need to have this value, s to the power 1 by 3 into h. Now for a stable equilibrium, of a circular cone floating with its apex downward, what is the condition? The condition is h square should be less than equal to 1/4 d square s to the power 1 by 3 minus 1 minus s to the power 1 by 3, where what is your h? H is the height of the cone, total height. Okay, total height of the cone. Okay, what is your d? Sir, d is the dia of the base, like base dia of your cone. Okay, what is s? S is the specific gravity of the cone, not the liquid. Okay, specific gravity of the cone. And x is the depth of submergence. X is the depth of submergence. Okay, x is the depth of submergence. So sometimes for EAC they will ask you to prove it. For engineering service exam they will ask you to prove it in conventional case. Otherwise you just remember this formula, d square s to the power 1 by 3 by 1 minus s to the power 1 by 3, and the depth of submergence is s to the power 1 by 3 into h. AEW PSU they directly ask this question. Okay, now note it down. So now we have come to the last topic of today's class, that is your experimental method of finding metacentric height. Sometimes they ask in exam. Okay, previous year they have asked this actually in exam. Now see, I have a ship, okay, and the weight of the ship is W, which is concentrated at center. B is the center of buoyancy and the force of buoyancy is acting through center of buoyancy. Okay. Now what I have done is, I have kept a load W dash on this ship. Okay. Now what I'll give it a disturbing couple. Because I have given it a disturbing couple, so now the ship has tilted. The ship has tilted. This is the back view of the ship. Okay. So this ship has tilted and it has made some angle. What is this angle? It has made theta. This theta is nothing but your angle of rolling, right? You move like this. What do you call? Rolling along the transverse plane. Already I have told this is rolling, this is pitching, this is yaw. Okay. So theta is nothing but your angle of roll. Very, very good. Okay. Now this is your center of buoyancy. Center of buoyancy has shifted. So the buoyancy force will now act through the new center of buoyancy. If we will join the center of buoyancy, it will meet at the axis where? At the metacenter. Already we have read all these things. Okay. So need not to worry. Same thing only I am telling. Now in this triangle, the triangle G dash M, this triangle. The triangle, this is your M, G dash. Okay, this angle is what? Theta. So what is G dash? Can you tell me what is sin theta? Sir, sin theta is G dash upon Gm. So your metacentric height Gm is equal to G prime. Sorry. So your G prime equal to, this implies, is equal to Gm sin theta. Oh wow, very, very good, fantastic. Okay. So now, so because it has tilted, the weight has shifted. The weight has shifted and came some distance. I don't know what distance it has come. It has come at certain distance of, let us say, x. It has come at certain distance of x. Okay. But this is the line, this is the line of action. Okay, this is how it has come. It has come at a certain distance of x, and this weight, W dash is acting here, correct? G, W is acting here. Okay, so I have a W, which is the mass of the weight of the ship acting on the centroid G, and W dash is the weight which I have kept, which has slipped at a distance of x, at some distance of x. Now, what is this angle? So the angle is theta only. This angle is theta. So if I will take two component of the theta, okay, this is theta, this is your x, try this. This is theta. What is this? 90 minus theta. If this is 90 minus theta, what is this angle? Theta. If this angle is theta, whatever this, sir, this is x cos theta. How much is the value? X cos theta. Now take moment about m. Take moment about m. So summation of moment about m equal to 0. What you got, sir? I can see two moment. One is w into gg prime. Another one is w dash into x cos theta. Correct na? Very good. Write it. So, w into your gg dash is nothing but w prime multiply x cos theta. Superb, very good. What is gg dash? Sir, gg dash is equal to, here you have wrote gm sin theta. Gm sin theta. Oh, wow, very good. Okay, so what is here? I got w prime multiply x cos theta. Superb. So this implies from this equation, what is my metacentric height? Metacentric height is equal to w prime x by gm upon cos theta by sin theta. This implies metacentric height is equal to w prime x by upon you should tell me w prime x upon w tan theta, or multiply up top में cot theta लिखो. This is your experimental method to find metacentric height. What is w prime x by w tan theta, where w prime is the weight added, and w is the weight of the ship. X is the displacement of w dash from centroidal axis. That's it. Over. So with this, your buoyancy and flotation over. Okay, next class you can find the derivation of the metacentric height. Okay, you will find that link in the description itself. Okay, and if you have any doubts regarding this, please feel free to write in the comment box. Okay, and we'll be solving some more numericals. And like, share and subscribe to the channel. And thanks a lot for watching, and clap yourself if you have watched till the end. Okay, have a great day ahead.